Most of us have seen aircraft being de-iced at an airport during the winter. Have you ever wondered how exactly this happens and why airlines do this? Obviously, the aircraft's wings are a critical part of an aircraft that needs to be de-iced before flight. However, the tail and portions of the fuselage also need to be treated. Allowing ice to build up would not automatically impede flight, but it would affect safety and aircraft performance in a number of ways. Ice on the wings would affect the aerodynamics, potentially reducing lift or making flight less stable. Ice would add weight to the aircraft, reducing performance and affecting calculations of fuel and range. Ice or snow could block vents or stop sensors from working correctly. And finally, any falling or breaking ice could damage the aircraft engines or airframe structure. When it comes to airport operations, snow and ice can cause massive disruptions. Thus, having a quick and efficient process in place to deal with this is essential, especially at busy airports. De-icing aircraft on the ground is a well-established process. The aircraft is first inspected to check for ice accumulation. If de-icing is required, a truck with de-icing equipment will be called. The aircraft will be positioned in a suitable area, one that has adequate drainage to collect the liquid, keeping it away from the ground watercourse. Sometimes this can be at the gate area, and sometimes the aircraft is moved to a dedicated area, usually closer to the departure runway. The aircraft will then be sprayed with a de-icing solution. This is usually a heated glycol water solution and will melt any ice accumulation. Usually, anti-icing solutions are applied next if there is a high chance of more ice forming before taxi and takeoff. This is usually propylene glycol. Ethylene glycol is also used but is less common commercially as it contains more toxins. The crew will spray the wings from the wingtips inward, avoiding sensitive areas. The de-icing solution also contains a dye that will help indicate which areas have already been treated. Timing is an important part of this process. Once an aircraft has been treated, it'll have a certain holdover time where it should start its flight. The treating chemicals help prevent ice reforming, but only for a period of time. Once airborne, the gel-like solutions disperse so as not to affect the wing performance. Additionally, all large aircraft have systems for de-icing in flight. At high altitude, any moisture that accumulates on aircraft wings can freeze. The most commonly used system passes hot air from the engines through a network of small tubes underneath the surface of the wings and the aircraft tail. This raises the temperature sufficiently to melt any ice that forms. On smaller aircraft, there are also systems which use antifreeze solutions on the wings and propellers, or electrical systems which use heated rubber surfaces. Have you been on a flight recently that needed to be de-iced? Let us know in the comments. Did you know that we publish over 175 stories every single week on simpleflying.com? Be sure to check the link in the description for more great stories just like this. Thanks for watching, and be sure to like and subscribe before you go.